Hi everyone, my name is Brianne Hargrove, and today I'll be giving some background on the research project I'm proposing for the Penn State EnvironMentors program. In this project, we will be looking at ways to reduce 3D printed plastic waste by recycling this waste to create new filament for printing. So first, a little bit about me. I'm a third-year PhD student in mechanical engineering at Penn State. I'm originally from Brooklyn, New York, and I also did my undergrad in mechanical engineering at Penn State, and I minored in Spanish as well. And throughout my life, I've always been interested in math, science, and designing and tinkering with things. So this was a major motivation for me going into engineering, and also because I didn't see a whole lot of people like me or from my community in the field. So me getting this degree was a way of proving to myself that I could be successful in a STEM field. When I first started grad school, I was a teaching assistant where I helped develop new lab courses for undergraduate students to kind of bring in more hands-on activities into the mechanical engineering program. Some of these topics included machine learning, acoustics and vibrations, and energy generation by studying wind turbines and wind tunnels. Currently, I'm a research assistant in the eDog lab at Penn State, and the main focus of my work is developing mathematical models for studying highly flexible structures known as compliant mechanisms. And with this, we want to compare these mathematical models with finite element analysis software and also experimental studies. An important part of my research is the use of nonlinear elastic materials, such as shape memory alloys, as shown here, which have a memory and return to their original shape when heated or deformed. And I've also looked at rubber-like materials such as 3D printer plastic filament, known as thermoplastic polyurethane or TPU. And 3D printing of plastics in particular is one of the things that we will be looking at in this research project. So now moving on to the motivation for this research project. Plastic waste poses a major problem to our environment since it's not biodegradable and ends up in large quantities in landfills, in the ocean, and even in the air. Towards the goal of environmental sustainability, we have standardized processes for recycling different types of plastics and even novel ways of using plastics to make new clothes, packaging, and in some places in construction to make roads. However, what happens to plastics that cannot be recycled? For example, plastics used in 3D printing. The 3D printing process involves filament that is fed from a spool into a heated nozzle, which is then deposited to form a 3D shape. The plastic filaments used in this process often do not meet the criteria for recycling of regular plastics, such as disposable water bottles. While 3D printing produces a lot less waste compared to traditional manufacturing methods, some plastic waste can still be produced. While one 3D print may be successful, another could result in failure of the 3D printed part. As a result, we could end up with several parts that are unusable. And to then get a functional part, we would have to keep changing the printing parameters and the settings until we can get a better print, resulting in waste of the material, because we have to keep printing over and over again. Some 3D models also require support material during printing to support overhanging parts of the model. And the support material is then removed after the print is finished. And this also contributes to plastic waste. So the objective of this project is first, how can we recycle the plastic waste generated during the 3D printing process to create new filament? And then also, how can we ensure that the recycled filament is good enough to be used for printing new 3D parts? So the first step of this project involves designing a tool or a method to break down a failed print or support material, melt that plastic together to fuse it into a new filament for printing. And then the second step is more of a validation of the process by saying that if we have this part that we want to print, for example, a compliant mechanism that looks like the GIF shown here, if we print it using the original standard filament that we bought, say, off of Amazon or some other manufacturing company, and then again with the recycled filament, would the mechanism printed with the recycled filament have the same performance, strength, or flexibility as the one printed using the standard filament? And then what would be the comparisons, the benefits, and the drawbacks between using the standard versus the recycled filament? So through this research project, I hope that you would get a hands-on experience and an opportunity to do some design work, which many students in STEM fields are introduced to in their first semester of college. Especially if you've never got to work on a design project before and you're interested in making and testing things, this project may interest you. And by learning more about 3D printing, also known as additive manufacturing, you'll gain some insight into this new and disruptive technology that industries and researchers are gradually shifting to prototype and design low cost, highly customizable products. Lastly, I hope to highlight the broader impact that you working on this research project will have on not only adding to the mission of a more sustainable environment, but also on the decision that you made to be a part of this STEM program and the encouragement that it will give to like minded students and youth in your own communities. Thank you for listening. Again, I'm Brianne Hargrove, and I really do hope that you enjoyed this program.